right, folks, it's Bass Action back in action here. In this video, we are now going to go the other direction with our rectangular and our polar coordinates. This time we're going to start with rectangular and we're going to end in polar. And as I mentioned in the last video, it is important to know which direction you're going because that direction is going to tell you the form that you originally start in. So if we're going rectangular to polar, then that means on example 5a here, the first point I'm given is in an XY form. So we need to get that into an R theta form, okay? In order to get it into an R theta form, we're going to use that equation of a circle that we talked about in the previous examples on the previous video when we were converting our equations. We're going to use that equation for a circle, and that's going to help us out here. So that's going to tell us that r squared, I'm just writing the equation backwards, that r squared is equal to x squared plus y squared. So that means that I can take a negative radical 3 squared plus a 1 squared, and you'll eventually do a lot of this in your head, and that's going to tell me that r squared is going to be 3 plus 1, or 4, so my r value for my polar form is going to be 2. Now I also need to be able to find the theta value, and just like we said that our x value was equal to our cosine theta, if we think back to our trigonometry, we know that tangent theta is going to be sine over cosine, or y over x. So our tangent theta is going to equal 1 over a negative radical 3. And if you think back to the unit circle, there's multiple places where tangent could equal a negative 1 over radical 3. And that's where we really need to think about, where does this point actually plot? So I encourage students to always make a quick little XY axis, plot that point in the rectangular plane, and that's going to be in the second quadrant. That's going to tell us where our theta value should be. So in the second quadrant, what theta value is a negative 1 over radical 3, and that is going to tell us it's 5 pi over 6. That's what's going to keep us from choosing the 11 pi over 6. So our final answer is we're just going to put those two together, r comma theta. The order you write them matters. Can't flip-flop them. And that's going to be our first one. So let's go ahead and do another one. So on B, we're going to have our r squared. We're going to, of course, again, I imagine most of you are going to ultimately do a lot of this in your head. We're using that equation of a circle, r squared equals x squared plus y squared. Okay, that was the last example in the previous video. So we've got our r squared, and we're going to have 3 plus 3 is 6. So our r value is going to be a square root of 6. Don't worry that it ends up being something kind of weird. That's not the end of the world there. Then we're going to do our tangent theta. So we'll have our tangent theta, and that's going to be y over x, so negative radical 3 over negative radical 3. So we want to know, where is tangent theta equal to 1, but we have to know what quadrant we're picking that on. So we're going to grab this. We're going to make a quick little xy axis. We're looking for, where is tangent theta equal to 1 in the third quadrant. So our theta value is going to be 5 pi over 4. Then we can put the two together and write our angle, or r theta. So there's our next one. Then we can keep going. We're going to do another one here. I'm going to streamline things a little bit for us. So the r squared on this one, now I'm going to do a little bit more in my head. Negative 6 squared I know is 36 plus 0, so my r is just going to be 6. If I plot this point, negative 6, 0 is right there. So I could go through the tangent exercise, tangent theta, 0 over negative 6, but I can clearly see exactly what my theta is supposed to be, so I didn't necessarily need to do it on this one. It's going to be pi. So our point in polar form is 6 comma pi. And then the next one, just like the last one of this form in the previous video, I didn't give you something from the unit circle, so we're going to end up with our r squared, and I'm going to have my 49 plus my 25 So my r is going to be the square root of 74. It's going to be weird, and that's okay. Then we're going to do a quick little plot of this. Where do we want this angle to be? So positive x, negative y is going to be in the last quadrant. So we're going to say tangent theta is going to be a negative 5 over 7, has to be y over x. And when I type that in my calculator, remember the calculator only knows the pre-programmed restrictions. So it's going to give us, I'm going to do it in degrees, it's going to give us a negative angle in the fourth quadrant, and it's going to give us a negative 35.5. We want to write our polar, when we're converting, we want to write those polar angles as a nice positive angle. So I do want to convert that to its coterminal angle, and I'm going to write that then as an approximately 324.5. So pulling that together, my polar form is a square root of 74. If it's simplified, I would do that, and 324.5 degrees. Okay. All right, then the last thing that we're going to do is converting back to the other form, taking equations and going the other direction. Just like before, this isn't a huge thing, but the more you can start to get a little bit comfortable with how these equations look in their traditional form for us and how they look in their polar form, the easier things will be for you. So recall that x is equal to r cosine theta, and y is equal to r sine theta. And then that equation for our circle that we just used, x squared plus y squared equals r squared. And when we convert these to the other form, what we're basically looking for is where we can do a little substitution of an x, a y, or an x squared plus y squared. So on this first one, clearly x, it can just then replace with r cosine theta equals 4, and I'm actually just done. So the whole point of this question, as basic as that is, to recognize that x equals 4 is going to be a vertical line in our rectangular form. And that means that a vertical line in polar form has this form. Okay, this is what our polar form is going to look like when we want to just graph a vertical line. On the next one, we have the x squared plus y squared, and I can just substitute that then with an r squared. And then I have a 16, and y I can see is immediately going to substitute to r sine theta. And traditionally in the polar form, we wouldn't include r's on both sides, so we're going to get rid of that, and we're going to write our equation as r equals 16 sine theta. And that is going to be the equation for a circle that's not at 0, 0 in our polar form. So again, it's just about starting to recognize that this is a form that you should be familiar with, and this is what its new form is going to look like. And then, like I said, when we get to our later sections, we're going to do a whole lot more graphing with this. In fact, that's the next section that we're going to do.